Hi, this is Bruce McConnell. Welcome back to Locomotive Systems Training. We're in air brakes. All right, so let's talk about it. There it is, air brakes basic. Got to have a foundation for it. LSTV-032. Here we go. Let's take a look. All right, so now it's 2015. That's a carryover from the last video. Let's talk briefly about what is out in the railroad industry regarding pneumatic air brakes. Now, from now on, we're just going to talk about pneumatic air brakes or air brakes. Yeah, that sounds about right. Mainstream railroads will normally use either 26L or 30A CDW type air brake systems. Those two systems are very, very similar. They pretty much operate the same except for a couple of pieces, which we'll probably get into a little bit later. Today we will discuss air brake components that are used in the 26L air brake system. Okay? Okay, so now we're going to talk about the 26C automatic brake valve. I'm the engineer and I'm sitting in the seat right here and I'm looking forward. I'm driving down the tracks. I got a 3-unit consist and 150 cars behind me. So I know, because I've driven this route before, that down the road there is Dead Man's Curve. So I got to slow down to go around Dead Man's Curve safely. So I grab this brake valve handle, I move it from release and recharge. Now I know the rail industry doesn't call it recharge, but there's a reason why I do. Because that's the only position where you can actually recharge the brake system. So I grab that handle from release and recharge, and I move that handle, and I go into the application zone, which is right in here. I make a 5, 10, 15, 20, 25 pound reduction of brake pipe. I know it doesn't make sense right now, but that's what I got to do to apply the brakes on not only my locomotives, but on the cars as well. So, and by the way, there's two types of valves in this air brake system. There's what they call an initiating valve, and then there's another type of valve called a responding valve. The initiating valves control the action of the brakes for that segment, and the responding valves respond to that initiation, and they do whatever they're designed to do. So you have initiating valves. This valve right here, ladies and gentlemen, is an initiating valve. It's an automatic brake valve, 26C. Okay, move the handle back and forth. That applies brakes. Move the handle back from right to left. Then you release the brakes. Okay? Again, this valve initiates application and releases of both locomotive brakes and train brakes by controlling equalizing reservoir pressure, which in turn results in controlling brake pipe air pressure increases or decreases. I always tell everybody when I teach this class, it does a lot of things, but its #1 claim to fame, in my opinion, this whole valve here is a brake pipe regulator. The way we regulate the brakes in the train is through brake pipe. From that lead locomotive, through that 3-unit consist, through those 150 cars to that last locomotive, that last car, or a locomotive, could be if it's distributed power. But again, we're going to stay with 26L, so we'll just say 3 locomotives and 150 cars, and we'll have an EOT on the back end of train device. Okay, so this guy, his job is to control brake pipe. Brake pipe goes up, brake cylinder goes down. Brake pipe goes down, brake cylinder comes up. It's like the teeter-totter effect. Okay? All right, let's go to the next valve. This is an SA26 independent brake valve. Now, if you've been paying attention to the last video, they actually had a sign up there that said SA. And what does SA stand for? Straight air. And what does straight air mean? That means air brakes right now. You move that little handle from release over here all the way over to the application zone. I'm getting brakes on my locomotives only right now. Okay? So it says here, as the name implies, this brake valve permits independent control, pipe 20 of the locomotive brakes, only separate from the train brakes. Another function of the valve is to provide an air pressure signal, pipe 13 to the 26F quick release valve, to exhaust an automatic brake application. Whew, say that fast 3 times, right? Okay, let me explain it. You move this handle from release, and the further from the left to the right you move it, brake cylinder goes up from 0. Depending on the J relay valve, great, now we got another valve to think about. Yes. But this valve here applies brakes on the locomotives only. That's the first thing you need to get straight. Locomotive brakes only. This does not go out to the train at all. Strictly locomotives. Move the handle from release all the way over, swings all the way over to the right. The more you move the handle from left to right, the more brake cylinder pressure gauge goes up. You're pressurizing pipe 20, maximum 45 psi. Now, another thing that the engineers have to do quite a bit is they'll make an automatic brake application. Let's go back to that previous slide for just a second. Oop, the other way. There we go. Alright, when I move this handle from release and recharge into the application zone, quite often operating rules will say they'll have to actuate or bail off the brakes in the locomotive. So now let's go back to the other slide that we were at. There we go. When you take this red handle, and again, don't go by that red handle, or this independent brake valve handle, that's even better. You push down in any position from release all the way over to the full application. You can push that handle down, and when you do that, you're going to pressurize pipe 13 here. Pipe 13, what it does, pipe 13 goes out to the locomotives only, and it will release the automatic brakes that the automatic brakes have applied. Now, why do we want to do that? Well, I want to refer back to the world of over-the-road trucking. Okay, you have a trailer and you have a tractor or truck, however you want to call it. A lot of times, as the operator of that vehicle is going downhill, and I don't know how they do it. I'd have to have you folks chime in and let me know. They would apply the trailer brakes and not the tractor brakes. And what that does in that situation, the trailer is actually slowing the tractor down or truck down. Same thing on a train, believe it or not. We're going to have the box cars slow down the locomotives, which means we're going to put stretch or draft or pull on every car all the way down to the front of that locomotive. We want the cars to slow the locomotive down. We keep the train tight or stretched, and it allows us for very good train control. So the two things that this guy does, he applies the independent brakes for additional braking. The independent brake can be used, so brake augmentation. The independent brake can also be, when it's applied, it can also be used as a parking brake for a standing train. Okay, so those are basically the two things that it does. But in addition to that, when we push that independent brake valve handle down in any position from release all the way to full application, I pressurize pipe 13, and the automatic air brake application that I had on there is nullified or vented away, and then but all the brakes on my cars are still braking, and they'll slow my train down or slow it down to a stop. And a very organized, very what's the word I'm looking for here? Organized as well as controllable. That's the word I want. Controllable manner. So it's controlled in a nice, orderly manner. All right, let's go to the next one. J relay valve. It says here, remember I said there's two types of air valves on 26L air brake equipment. One is a initiating valve. Well, the 26 Charlie or 26C automatic brake valve is an initiating valve. The SA26 independent brake valve is an initiating valve. The J relay valve is a responding valve. It responds to an air signal from either the independent circuit, pipe 20, or automatic pipe circuit, pipe 16, that provides a large volume of air, which is the main reservoir air, to the brake cylinders. The diaphragm or diaphragms contained inside this valve determine the output of air to the brake cylinders. There are three different types of J relay valves. One is non-multiplying. We'll talk about that in a minute. The next is multiplying up. Okay, this is getting a little strange. And then we have multiplying down. Let's go back and look at them. Let's say, go back to the independent brake valve for just a second, please. Let's say I apply this from release all the way to full application. I'm pressurizing pipe what? That's right, pipe 20. I'm going to fill the maximum of 45 psi or pounds per square inch. Okay? With that fully applied, now go back to the J relay valve. It'll send an air signal, pipe 20, down to this valve. Main reservoir located at the top of this valve. And by the way, main reservoir is the granddaddy of all the air in the air brake system. He pumps in at 130 to 140 psi. That's the largest or highest pressure in the system. But pipe 20 is only 45 pounds. So this input signal this guy gets is going to say, this guy wants full independent application. I'm going to put in an input of 45, the upper diaphragm, 45 lower. I'm getting a little ahead of you here, but that's all right, bear with me. 45 here, 45 here. Output going out to the brake cylinder is going to be a total of 72 pounds. It's based on the percentage of the diaphragms that are in here. Okay? And if you have questions, give me a call or send me an email and we'll give it more. Anyway, a non-multiplying J relay valve, if I put 45 pounds in, how much air am I going to get out to the brake cylinders? Yep, 45 pounds. If I have a multiplying up of the J1 414, J1 616, a J1 818, or a J200, any four, like I said, I would have had a 45 pound pressure. That pressure goes in, and the output is greater than the input, that's called a multiplying up valve. Okay? Multiplying down valve, J16B, J46B, J64B, J84B, or J84M. This you'll find this mostly on the older locomotives that have been retroed to go from cast iron brake shoes to the low friction or high friction comp brake shoes. Okay? And what we'll do, the signal, the air signal now, is because they're so effective at braking, they actually had to knock the pressures down, otherwise they'd actually lock up the wheels. So this signal would go in at 45 and the output pressure would be something less than that. So not multiplying, 45 in, 45 out, multiplying up, 45 in, pressure greater, multiplying in, 45 in, pressure less than 45 output. So, and there's a whole bunch, as you can see from here, a whole bunch of J relay valves. All this guy does is a responding valve, and he takes the signal from pipe 20 in the independent circuit or pipe 16 in the automatic circuit and sends an output signal over to the brake cylinders. A lot of people think when you move that handle, either handle in either the automatic brake or the independent brake, that air signal actually goes down and fills them up with air. That is not true. All that signal goes is from the automatic or the independent to this guy through a couple of check valves and other little things. And this guy says, based on what handle I moved, based on what circuit I'm in, this guy will send the output to the brake cylinder. Let's go to the next one. Okay. I need to go back all the way to the automatic brake valve. There we go. All right. The 26C automatic brake valve is an initiating valve. We've already discussed that. When I take the automatic brake valve, move the handle into the service zone, I'm reducing equalizing reservoir pressure and brake pipe pressure. I want to create pipe 16 signal pressure. Now let's go back to where we were there. That reduction in brake pipe is felt inside this valve and also in this side valve. So let me explain what they are. This here is the 26F service portion. This right here is the pipe bracket. See all the pipes coming up and bolting to the bottom of it. And the little guy on the side here is called the 26F quick release valve. There's three components in the 26F control valve. That's the pipe bracket, service portion, and quick release valve. Now, this guy responds from that handle movement in the cab. This guy's job through the whole, and I'm not going to go into it because then you're talking intermediate air brakes, and that's a whole different level. This guy converts that reduction of brake pipe inside here into a pipe 16 signal that goes over to the J relay valve. Okay? Full service rate reduction on here will be a reduction of brake pipe from 90 down to about 65. So now I've got 65 pounds of brake pipe inside this valve here. That valve is going to produce a signal 2.5 times that reduction. In other words, when brake pipe reduces, this guy senses the reduction. He says, okay, if I made a 10-pound reduction, I need 10 plus 10 plus 5. That's 2.5. Old school math, right? Then I'm going to build a pipe 16 signal. I'm going to send it down here. And it's going to come over and go to the J relay valve. So if I made a 10-pound reduction, that's 10 plus 10 plus 5. I'm going to send a 25-pound signal in pipe 16 to the J relay valve. And the J relay valve is going to spit out 25 pounds of brake cylinder pressure. Hopefully you got that, but if you have questions with it, send me an email or give me a call. Anyway, this is what the control valve is. This guy controls the brakes on each locomotive. Every locomotive has one of these control valves, and every car has its own type of control valve. And they all run off the signal of brake pipe either increases or decreases. Okay, let's go to the next one. And guess what? Well, here we are at the end. So, again, just so you know, this is our website, www.lst-ca.com. Once again, that's www.lst-ca.com. And by the way, that is not, even though it looks like a number 1, it's not, there are no numbers in any of our web addresses. No numbers at all. Okay? So go there, take a look, leave a message, give me a call. I got all my phone numbers there. I have other stuff. And we just, by the way, we just revamped the basic air brake class, and it's awesome. So if you're interested, give us a call. You got the website. Thank you and have a safe day.